I welcome you all to the session of engine system and performance, and today we shall discuss about speed control of internal combustion engines, and then we will see one important mechanical device which is used to control the speed of internal combustion engine. If we recall our previous classes, then we will can understand that electronic control unit or engine management system, as such we had discussion on this particular topic, and we had seen that there are many sensors, and these sensors are used to sense or monitor a few variables, and thereafter sensors upon sensing a few variables provide some input to the engine management system, and engine management system upon receiving signals from the sensors provides feedback to actuators to control to adjust to the changes. That means, engine management system is responsible to provide some input to the actuators to adjust to the changed conditions. Traditionally, internal combustion engine, rather control of internal combustion engine has been based on sensing as well as monitoring some variables, and those variables are engine speed, intake manifold pressure, coolant temperature, oxygen concentration in the exhaust gas, all these things. We have discussed in detail about all these variables in the context of electronic control unit or engine management system. Now, we have also seen that engine management system for the modern engines is very crucial for a smooth and optimum operation of the engines. So, all these sensors we have seen that intake manifold sensor, exhaust gas oxygen concentration measuring sensor, coolant or measuring the temperature of coolant sensor, then measuring speed, there will be a sensor. So, all these sensors are used to get some input from several parts of the engine, and then these sensors are used to produce some signals, and those signals will be received by the engine management system. So, as I told you that traditionally control of internal combustion engine has been based on monitoring and sensing, rather sensing and monitoring some variables, as I said you already, engine speed, coolant temperature, exhaust gas oxygen concentration level, then fuel flow rate, all these. Now, we have seen that electronic control unit or engine management system upon receiving feedback from these sensors does some task essentially to control a few parameters, and what are those parameters? Say for example, spark timing, fuel injection timing, then fuel flow rate, then exhaust gas circulation rate. So, these are very important to know that sensors will be responsible to receive some information about all these variables. Receiving all these variables, sensors will give some input to the engine management system, and engine management system upon receiving all these input will do some task essentially to control a few parameters. Those are responsible to again monitor or bring this fuel flow rate, coolant temperature, spark timing, fuel injection timing to the baseline condition. Now, what is a baseline condition? So, if I write here, so sensors sense as well as monitor some variables, and those variables are, as I said, engine speed, coolant temperature, then oxygen concentration, in the exhaust gases, then intake manifold pressure, which is also very important, etc. Now, this from these sensors feedback will receive feedback of this. So, feedback of these variables will be received, feedback of these variables will be received by the ECU or electronic control unit, okay. Feedback of these variables will be received by the ECU, and then ECU, as I said you, controls parameters such as spark timing, then spark timing, then I should write here, fuel flow rate, fuel injection time, exhaust gas recirculation, etc., to a baseline condition. To a baseline or to baseline conditions, I should write. So, this is very important. Let me underline these two words. That means, electronic control unit or engine management system is responsible to fix these parameters to baseline conditions. What is a baseline condition? Baseline condition or baseline conditions are measured on a test engine, right. So, essentially when an engine is taken for testing, essentially to estimate performance parameter, then all optimum parameters are certified with the engine before it goes to the market. So, electronic control unit or engine management system will be responsible to correct, if there is any issue or error, to correct those errors through control of some parameters, so as to engine can be operated always with baseline parameters or with baseline conditions. Now, question is, we all have studied that internal combustion engine typically runs for a wide range of speed and load. Now, question is, if it is so, then during operation speed will be changed or load will be changed. This is quite obvious and intuitive. Now, knowing fully that internal combustion engine can operate or will operate rather for a wide range of speed and load, during operation the speed or internal combustion is responsible to adjust speed to a value, so that the power output would be in line with the external power requirement. let me repeat this line once again. Knowing fully that internal combustion engine will operate for a wide range of speed and load, during its operation there will be some unit which will allow engine to adjust or engine to run with a speed or to adjust speed to a value, so that power requirement should be in line with the requirement or external power requirement. So, what you can understand from this line essentially, then either speed has to be adjusted or power requirement has to be adjusted. The question is, in this context, since the topic of our today's discussion is speed control, in this context the control is referred to as regulation of power, that is output, so that speed or required speed is obtained, right. So, since the topic of our today's discussion is speed control of internal combustion engine, in this context control is referred to as regulation of power, so that the required speed is obtained, right. So, let me write this line again. In this context, the word control, that is the topic of our discussion in today's class, refers to as regulation of power. That is very important. I should write output power. So, let me erase this. Of output, so that required speed is obtained. So, this is what is important to know, at least in the context of today's class. So, henceforth we shall be using the word control quite frequently, and the control here will refer to as regulation of output to obtain required or desired speed. Let me tell you once again. So, what we can understand, the required speed is obtained. That means, somehow there will be some mechanisms by which, even though output will vary or output can vary, but the speed will remain more or less same. That means, we are trying to have a control over the engine speed. So, for speed control, essentially we shall be discussing in today's class about the speed control. So, speed control, so for the speed control engine or for the constant speed operation, that is what we can understand. We are looking for the operation of an engine at a constant speed, though the power can vary, but there will be some mechanisms so as to maintain the speed of the engine more or less constant. So, for constant speed operation, let me write a few words, then again I shall explain this. For the constant speed operation, the output is changed, so that speed, so that the speed does not almost change with change in external power requirement. external power requirement. So, we are doing this discussion just for introductory discussion for this topic, that is speed control. We shall discuss about what is speed control, why it is necessary in the context of engine operation, and then what are the possible avenues or methods available to bring a control over over the engine speed or over the speed of the engine. So, for the constant speed operation, what we can see from this particular line, for the constant speed operation, as we can see that though the power output will vary, but mechanism or inbuilt mechanism will try to maintain the speed almost constant, and that is what we can see from this line. The speed does not almost change with change in external power requirement. So, this is for the constant speed operation. So, if I just put it in this circle, then we can understand that if we really need to have a control over the speed of the engine, there must be some mechanism, and that is why the term governor, which perhaps you have studied in your undergraduate internal engine course, or even you have studied in your dynamics of machinery course. So, governor, which are again a mechanical device, and the function of a governor is to govern some functionalities. So, here for the constant speed operation, the output is changed, as I said you. Now, we need to maintain the speed more or less constant, and that is why engines are provided with speed governor, or which is also known as speed control or constant speed governor, and the function of this governor is to regulate speed. I mean the speed should be controlled by that particular mechanical element irrespective of the load variation, right. So, from this line we can understand we need to have a control. It is not really possible to maintain the speed should remain almost at a unique value, but it is with a close variation, right. So, mechanical governors, that is either it is a mechanical governor or electronic governor, that we will study soon in this class in the later part of this class. So, what we can understand that engines are provided with speed governor, which is also known as constant speed governor, and the sole function of this governor is to regulate speed of the engine with the power so as to maintain almost constant output. So, that means speed of the engine will remain constant irrespective of the load variation. Let me write again a few lines for this. So, if I write here, what we can understand that engines are provided with a speed governor which is also known as constant speed governor. Constant speed governor, and the function is governor which regulates the speed within the speed within a close range during load variation. That is what I was talking about. So, that means it is not really possible to maintain the speed exactly unique all throughout the operation of an engine, but essentially this governor or mechanical device will try to bring a control over the speed so as to maintain the speed within a closer or close range during load variation. So, this is basically speed control governor. Now, the question is, it is not only a case that engine or engines are always provided with a speed or constant speed governor. So, even if the requirement arises, because variable speed engines, for the variable speed engines, because there are some applications for rather applications of the variable speed engines. So, for the variable speed engines there are some problematic issues, and to encounter all these problematic issues I will explain soon. Variable speed engines are provided with maximum speed governor. So, now what we can understand from the discussion we had until now, engines are provided with speed control governor or constant speed governor, so as to maintain the speed constant irrespective of the load variation. Constant means with a closed range, and then as I said you, there are some applications wherein we need to have variable speed engines, and even for the variable speed engines there are some problematic issues. If we do not have any mechanism to control the maximum speed, and that is why variable speed engines are provided with maximum speed governor, and let us now discuss what is this governor, that is maximum speed governor, and then how this particular governor is responsible to maintain the speed constant for the variable speed engines if situation demands for. So, if we go to the next slide, as I told you that variable speed engines and variable speed engines, as I told you these engines are provided with maximum speed governor. Okay. So, the function of this particular governor is to limit the maximum speed of the engine. Why it is so, and why do we need to have this type of governor in the context or in the operation of variable speed engines. So, since the engine is variable speed engines, you can understand typically these variable speed engines experience variable speed engines experience problematic issue. Variable speed means speed can go even up to higher level. So, when speed becomes very high, then we need to prevent the racing of the car or of the engine, right. So, experience problematic issue with the higher speed at higher speed. What will happen at higher speed or speeds we should be able to control or to prevent the engine from racing. What is racing? So, this is known as racing of the engine. The problem is racing of the engines. Why it is? So, basically that speed will be so high that let me tell you one thing, that if the speed increases abnormally or beyond the limit, then there will be some problematic issues with the CI engines or diesel engines. You know that compression ratio of the diesel engines is higher than the compression ratio of SI engines. Now, constructional point of view, certainly diesel engines are very heavy, bulky, and that too the rotating parts of the diesel engines are also very bulky, right, heavy rather. So, if the engine is allowed to run at a very high speed, that may happen if there is a sudden drop in load on the engine, right. So, for example, if it is a SI engine, so when full throttle, so there will be a sudden drop in load on the engine, and for the CI engines when so just if I write to the next slide. So, engine can run at very high speed when there will be a sudden drop in load on the engine, and this drop in load on the engine can be, so if it is a SI engine, then suddenly when engine is allowed to run with full throttle. If it is a CI engine, then if engine is allowed to run with maximum delivery setting. So, when engine runs at maximum delivery setting. Okay. So, these settings. So, these two situation, I mean engine can experience at any time during its operation. So, if it is a SI engine, then if the engine is running or engine runs at full throttle condition, that means there is a sudden drop in load on the engine. So, engine speed will increase. If engine speed increases, then that the problem is known as racing of the engine. The question is, so long as the engine is SI engine, compression ratio is small and engine is not bulky, still it is manageable. But the problem is with the diesel engines, because for the diesel engines, as I said you, compression ratio is higher, engine is bulky, and construction of rotating parts of the engine is also bulky or heavy. Now, the question is, when the engine is rotating at high speed, then inertia as well as centrifugal force of those rotating parts will be so high that it may damage those parts, and that sometimes sometimes what will happen that high inertia and centrifugal force may cause them to fly apart. So, let me tell you once again, for heavy or bulky shape of the engine or rotating parts, when engine will attain very high speed, inertial effect as well as centrifugal force of those rotating parts will be so high that those parts may become non-functional, and that too that high rotation, high centrifugal force and inertial effect may cause them to fly apart. So, all these problematic issues are there with the CI engines, and that is why if I go back to the previous slide, you can see that in the context of variable speed engine, engines are provided with, or engine is provided with a maximum speed governor, so as to limit the speed of the engine, so that engine can be saved from these undesirable effects. Now, the question is, another important point I would like to discuss here, that so just I am completing quickly. So, this maximum speed governor is responsible to control the speed of the variable speed engines I am putting these variable speed engines within inverted comma, so that rotating parts of the engine can be saved from their failure because of high inertia and centrifugal force at high speeds. So, this is what is important. So, this is all about that variable speed engines are, I mean we can understand the reason behind the use of maximum speed governor for the operation of variable speed engines. Now, even for the variable speed engines there must be a minimum speed governor. So, let me discuss one line. So, again here we need to have minimum speed governor. So, let me tell you, so if the engine is a variable speed engine, there must be two different types of governors. One is maximum speed governor, so as to allow the maximum speed of the engine, and we can save engine from their possible failure at with the problem associated or with the associated problem at high speeds. On the contrary, we also need to have a minimum speed governor to be equipped with the variable speed engines, because if we try to recall the torque versus speed curve of the diesel engine, right, and you will see that with torque is essentially what I can understand. So, output is essentially torque into omega. So, torque versus speed curve, if you can recall correctly, you can understand that if speed increases, or what I can say that basically load. So, this is load and this is speed. So, when load drops, then you can understand when load drops, to maintain constant torque, the speed will increase rapidly, right. So, when speed to maintain constant, when speed drops. So, if I can understand, then tau equal to p by omega. So, what I can say that the speed will increase rapidly. So, speed will increase rapidly when load on the engine drops. So, when load on the engine drops suddenly, right. So, the speed will increase rapidly. So, again that means there must be a minimum speed governor so as to have stable operation of the engine, right. So, we must have a minimum speed governor. So, this minimum speed governor is allowed to be incorporated to the engine, so that engine can have stable operation at low speed. So, that means when there is a sudden drop in load, we can understand from the torque versus speed curve that speed increases rapidly, and there must be a minimum speed governor. So, from the discussion I had until now, what you can understand, that control of the speed or speed control of the engine is essential, because in most of the cases it is not the variable speed engines. So, even for the constant speed engine, I mean the power or output should be adjusted to meet the demand of the external requirement, and for that speed can increase or speed can decrease, but there must be some mechanism to maintain the speed constant, and this is done by using a mechanical device which is known as governor. So, we shall discuss about this particular mechanical device, that is governor, which is used to control the speed of the engine in the next class. So, with this I stop here today, and we shall continue our discussion in the next class. Thank you.